Hierarchical clustering is a popular unsupervised machine learning technique used to uncover underlying structures and patterns in data. Developed independently by several researchers, including Robert L. Wilder and Joseph B. Kruskal in 1963, and Maurice S. Johnson in 1967, hierarchical clustering offers a flexible and intuitive approach to clustering analysis. We will provide a comprehensive summary of hierarchical clustering, its key concepts, algorithms, and notable contributions by authors in its development. 1. The concept of hierarchical clustering. Hierarchical clustering aims to organize data objects into a hierarchy of clusters based on their similarity or dissimilarity. Unlike other clustering techniques, hierarchical clustering creates a tree-like structure, known as a dendrogram, that displays the nested relationships between clusters at different levels of granularity. 2. Agglomerative and divisive hierarchical clustering. There are two main approaches to hierarchical clustering, agglomerative and divisive. Agglomerative clustering starts by considering each data point as an individual cluster, and then iteratively merges the most similar clusters until a single cluster is formed. Divisive clustering, on the other hand, begins with all data points in a single cluster, and recursively splits the cluster into smaller clusters until each data point is in its own cluster. 3. Distance metrics. To measure the similarity or dissimilarity between data points, various distance metrics are used in hierarchical clustering. Commonly employed metrics include Euclidean distance, Manhattan distance, and cosine similarity. The choice of distance metric depends on the nature of the data and the problem at hand. 4. Linkage criteria. Linkage criteria define the distance between clusters and play a crucial role in determining the order of merging, or splitting clusters in hierarchical clustering. Different linkage criteria include single linkage, complete linkage, average linkage, and Ward's method. Single linkage considers the minimum distance between two clusters, complete linkage uses the maximum distance. Average linkage calculates the average distance, and Ward's method minimizes the increase in total within cluster variance after merging clusters. 5. Algorithms for hierarchical clustering. Hierarchical clustering can be performed using different algorithms. Notable algorithms include the single linkage algorithm developed by Robert L. Wilder and Joseph B. Kruskal in 1963, the complete linkage algorithm proposed by Maurice S. Johnson in 1967, and the Ward's method introduced by Joe H. Ward Jr. in 1963. These algorithms employ different strategies for calculating distances and merging or splitting clusters. 6. Dendrograms. A dendrogram is a visual representation of the hierarchy of clusters created by hierarchical clustering. It displays the merging or splitting of clusters at different levels, revealing the relationships between data points and clusters. Dendrograms provide insights into the structure and similarity patterns in the data. 7. Notable contributions. Hierarchical clustering has seen notable contributions from various authors over the years. Robert L. Wilder and Joseph B. Kruskal introduced the single linkage algorithm in their paper, Finding Clusters in 1, 2, or 3 Dimensions, published in 1963. Maurice S. Johnson proposed the complete linkage algorithm in his paper, Hierarchical Clustering Schemes, published in 1967. Joe H. Ward Jr. introduced Ward's method in his paper, Hierarchical Grouping to Optimize an Objective Function, published in 1963. These contributions significantly shaped the field of hierarchical clustering and its applications. 8. Applications of hierarchical clustering. Hierarchical clustering finds applications in various domains. It is used in biology to analyze genetic data and classify species based on their similarity. In marketing, it helps segment customers based on their purchasing behavior. It is also applied in document clustering, image analysis, social network analysis, and anomaly detection, among other fields. The flexibility and interpretability of hierarchical clustering make it a valuable tool for exploratory data analysis and pattern discovery. Hierarchical clustering, developed independently by researchers like Robert L. Wilder, Joseph B. Kruskal, Maurice S. Johnson, and Joe H. Ward Jr. in the 1960s, offers a powerful approach to uncovering underlying structures in data. With its agglomerative and divisive strategies, distance metrics, linkage criteria, and dendrograms, hierarchical clustering provides a versatile and intuitive method for clustering analysis. The contributions of these authors have significantly advanced the field and laid the foundation for its applications in various domains. Hierarchical clustering continues to be a valuable technique for data exploration, pattern recognition, and data-driven decision-making across industries.